Hi there guys, I just came across this question today with my class in the textbook, and we were just having a good chat about how to go about doing this sort of a question, because at first it looks quite easy, but there's just a few things that will make it easier for you because it's not as easy as it looks to begin with. Okay, so essentially the question is asking you to complete the missing areas of the other fractions so that all of these four fractions are equivalent to each other. Equivalent being that they have the same value, but the numbers are different. Right, so the first thing you need to do is to identify out of the four fractions there, which one is already complete. So it has a numerator and a denominator. That's that one, of course. Okay, so the mistake, or the first thing that some boys in my class did, was that they just tried to go from one to the next, to the next, to the next. You can do that, but it's just not the easiest way to do it. What you should do is to firstly identify the fraction that's complete, and then have a look at the other three and look at, well, which one is the easiest one to change to begin with, okay? So for me, it would be this one here. All you need to ask yourself is, what have I done to this numerator here, or what are you going to do, to change it into this numerator here? And you have changed 3 to 6 by multiplying it by 2. So the golden rule, of course, is whatever you do to the numerator, you do to the denominator. So I'm going to times that by 2, and that gives me my missing denominator, and my fraction is 6 out of 10, or 6/10, which is equivalent to 3/5. Right, and now when I look at the other ones, you can easily go from 3 to 60 by timesing it by 20. Okay, so again, whatever I do to numerator, I do to denominator, and I'm going to have 100. Now you could have also chosen this one as an easier version, and you would have got the correct answer there as well. Okay, so for this one, it's kind of difficult to go from 100 to 35 and then from 60 to whatever. So you can choose any of the other two fractions to manipulate. And for me, I think this fraction here, again, would be the easiest one to do that. So hopefully I'm not drawing all over the place and getting this too confusing. I'll do this one in black, hey? So going from 5 to 35, I have times by 7. And from 3 to times by 7, I would get 21. Okay, and so there's my equivalent fraction. So you can go from any fraction to another, but you would start with the one that's complete and just do whatever is the easiest conversion, okay, with the numbers that you're familiar with by multiplying and dividing if you need to.